is for NS293 ENav. I got all the tools I need here. I got my dividers, I got my pencil and eraser, I got my 2 triangles, I got my transfer plotting sheet. Okay. And what we're going to do is I'm going to take you back to the first week, exercise 1, which focused on special cases. In this case, there's going to be 5 targets. One of them is going to be a problem target. The other 4 will be special cases. The difference between week 1 and what we're going to do today is that I'm actually going to create an MX and a new desired CPA for the problem target. I'm going to work that all out in front of you. And my goal is to do all that in 12 minutes, and that should be your goal as well. So we'll see if we're able to do it. So over here is our radar screen. I'll be plotting here. First thing I'm going to do is, you can see here we're making 000 at 15 knots. So I'm just going to go ahead and set that up. Okay, I'll get my radar plotting sheet set up. Okay, so this is my heading here, 000. This is just my EBL and VRM on here. So I'm going to mark my targets from my heading flash going clockwise. The first one I come to by bearing, it's going to be this. This is going to be target 1. Okay, that's going to be target 1, and I'm going to collect data for that at 06. Really, in reality, I'd also collect it for 12, but today I'm only going to do 0 and 6. And then this is going to be target 2 here. Okay, and I'm getting that set up. This will be target 3, and that's going to be over here, and 0, 6, and 12. And this will be target 4. That's going to be up here. 0, 6, and 12. This will be target 5. I don't have a convenient little box for that, so I'm just going to go ahead and I'm going to put that here, and I'll go 0, 6, 12, and you can see it's bearing and distance, so I'll go bearing and distance, okay, and I'll collect my data there for that. All right, so let's go ahead and get started. The first thing I'm going to do is I'm going to mark all my targets. By the way, I'm in 12-mile scale, and so that I'm going to be using here. If I'm making 15 knots in 6 minutes, I'll go a tenth of 15, which is 1.5 nautical miles. I'm not going to be using any other scale. If I wanted to, I could even just cross them out. If I was on a different scale, though, 6 miles or something like that, I would use. But anyway, since I'm on 12-mile scale, this has to match up with the range on your radar screen. Okay, let's go ahead and get started. All right, first thing I'm going to do is going to mark my targets. All right, so to do that, I'm going to go down here to Tools and click Add. So I'm marking target 1 now. All right, and now I'm going to mark, here we go, I'm going to mark target 2. All right, I'm going to mark target 3. Okay, now I'm going to mark target 4. All right, and I'm going to go mark target 5 now. Now I marked all my targets, and what I'm going to do now is you can see it took me about 30 seconds to mark all those targets. All right, so this one was actually, I did this one at about noon, 12:00:00. This one was 12:00 in 30 seconds. When I come back and mark these again at minute 6, I'm going to mark them in the same order. And what that means is that it's going to take me about 30 seconds to get to this one. But this one I got here at noon and 30, noon 00:30. Well, I'm going to do noon 6 and 30, and that's going to be 6 minutes. So by doing them in the same order, I'm going to actually end up having them all be about 6 minutes apart. All right, so now that I got them marked, I'm going to go back and I'm going to pull the range and bearing for each of those marks off of the radar. I can do that now a little bit at my leisure. All right, so... All right, here we go. I'm right up there. It looks like that is 9.84. I could say that's 9.8, and the bearing seems to be 007. So I'm going to go, bearing is 007, 9.8. Okay, I'm going to write that down for target 1. All right, and now I'm going to go ahead. I'm going to get that for target 2. All right. Oh, I think that's actually 9.9, okay? 9, not that that matters too much, but we'll go ahead and I'll make that 9.9, okay? All right. All right, let's see here. Seems to me that target 2 is going to be at about 10 and 0.044 and about 10, okay? So now I'm going to target 3. And it looks to me like target 3 is about 6 and 135, okay? About 6.0 nautical miles. All right. And now I'm going to target 4. And target 4 looks to me to be about 7.3 nautical miles at a bearing of 200. That's target 4. 7.3 at 200. Great. Now I'm going to target 5. And target 5, to me, that original mark looks to be about 9.8 at 3.7. 9.8 at 347. Okay, so let me get that 347 here. 347, 9.8. Okay, so now I've got all that. So what I'm going to do now is I'm going to do some plotting, okay? And I'm going to pay attention to the clock. So, target 1. Okay, target 1's bearing is 007 at 9.9. So I'm going to go here, and there's a couple different ways you can do this. I'm going to go ahead and get my distance set. All right, 9.9, and that's at 007. So I'm going to make just a little thing here for that. 9.9, 007. All right, I'll get that lined up there. Okay, so that's the R for that, and that's target 1, and that's R. All right, now I'm going to do target 2, 044 at 10.0. So here, 10 is pretty easy. I can just use the rings there. So 044 is there, and I go like this, and that's target 2. That's R for target 2. All right, now I'm going to go on to target 3. It's 135 at 6. That's pretty easy too. I don't have to actually measure off of here. 135 is here. I'll put my pencil down. I go like this to the center. 2, 4, 6. Okay, that's target 3, and that's R. And then target 4 is 7.3. I am going to have to measure that, so I get my dividers. And I'm going to go 7.3. All right. Oh, looks like my pencil might be breaking. And that is 7.3 at 200. So I'm going to go like this. 200 is about here. All right. So now I'll go, I got my range. I'm going to get 200. All right. So this is going to be target 4. All right. And that's R there. And then target 5 is 9.8. So I'm going to have to get my dividers out here again. 9.8. And that's at approximately 347. So there's 345, 347-ish, something like that. All right. So I'll get 347. I'll put my pencil down there, put my triangle up against it, and voila. So that's going to be target 5. Okay, and that's R for there. Okay, great. So let's look at the clock here. We're about 4 minutes into the simulation. So what I'm going to do now is I'm going to plot my E. So to plot my E, I'm going to take my heading, all right, my heading flash, and I'm going to reproduce that towards R for each one of these, okay? So I'm going to do this. All right, and it's got to be at least 1.5 nautical miles long. All right, because I'm going to put my, that's going to end up being my distance in 6 minutes. And this is the beginning of my ERM triangle. Okay, and let's see here. All right, let me bring this over here. I'm headed to the north, so I'm going to go like that, and target 5 is there. So I go like that. Okay, now I'm going to take a quick look at the clock. I've got 40 seconds or so, 20 seconds. So I'm going to set this for 15. Okay, and so I'm going to go ahead and just get my E's for all these. And then I'm going to come back and get my M's. Okay. So now, by the clock, oh, it's just the time. So what I'm going to do now is I'm going to go ahead and I'm going to mark all my targets again. So there we go. I put that on there. And that one, that first one looked to me like that was at 8.5 at 009, 8.5. And this second guy here, this target 2 looks to me like that's about 8.3. okay, at 044, okay, and let's see here. All right, now we're going to go on to target 3. Add for target 3. Okay, and target 3, the data for that was 6.0 at 135. So, okay, 6.0 at 135. All right, now we'll go on to target 4, and the data for that looks to me like that's about 6.0 at 206. Okay, so that's 6.0 at 206. And now we'll go ahead and we'll get the data for target 5. Okay, I'm going to add a mark for that. And that to me looks like that's about 7 miles at 341. Okay, so 341 at 7.0. Now, look, before we even continue, I just want to take a look at these. Bearing changed, but very slowly. Okay, and the thing got a little bit closer. Here, look, the bearing is constant. It has not changed. All right. And the target is getting closer. This is going to give me a CPA of 0. This is a dangerous target. And if I'm going 0, 0, 0 and its bearing is 044, it's on my starboard bow. That means vessel. Here, the bearing is 135, both cases. Oh my God, it's constant bearing. But the range has not changed. Okay? Right off the bat, if its bearing isn't changed and the range hasn't changed, that vessel's going the same course and speed as I am. I know that off the bat, but I'm going to show you how you can figure that out later on. This guy here, looks like his bearing is changing a little bit and increasing, and the range is decreasing. That's this guy. Okay. Anyway, and there's target 5. So I'm going to go ahead and plot those second M's now. Okay. So let's go ahead and do that. So 8.5. I'm going to do target 1 here. $8.5. Okay. So target 1, that's 8.5, and the bearing was 009. Oh, wait a second. Let me just fix this. All right. So this is E, 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 E. Okay. So this guy was 009. All right. Oh, look at that. That M looks like it's right about where that E was. Okay, interesting. We'll come back and look at that in a minute. Let's check out this guy. All right, so what's the M for target 2? The M for target 2 is 044 at 8.3. All right, so 8.3. All right. So I know this is the problem target. Let's see here. 8.3 at 044. So that's going to be about here-ish. All right. And 044. All right. There we go. All right. So that's going to be M right there. Okay. And I'm going to go ahead. There's the relative motion line. Yeah, going right through. Relative motion line here. Look at that. That's about a CPA of about 2 miles. This one here, geez, that one's kind of close. That's going to be less than 2 miles, about more than 1. This one's going to be about 2. I'm not too worried about that guy. Let's get the M for target 3. For target 3, it's 135 and 6. Oh, it's exactly the same thing. So M is here. That doesn't look to me like that vessel's getting any closer to me. Oh, okay, so it's at its CPA right now. That vessel is going the same course and speed. We'll come back and analyze that. Let's go ahead and do target 4. 6.0 at 206. That's not too hard to plot. I'm going to go here, 206 and 6.0. That's about right here. Okay, so I'm going to say that that is M. All right. And there we go. Okay. And target 5 was 341 at 7. 7 I'm going to have to measure because I don't have a convenient range ring for that. All right. And it's 341. Okay, 341. All right, so that goes about right there. All right. And so I'm going to draw that down like this. And that. All right, so this is obviously a problem target. The relative motion for this, there is none. Relative motion for this guy, he's going up here. He's going to be, I don't know, 2.5 miles CPA. This guy here, he's going to be more than 2 miles CPA. This one is going to be a mile CPA. But this one, so I'm thinking about that, but this guy right here is the problem target. I'm going to have to alter course to starboard for this guy, and that may actually make this situation a little bit better too. So let's go ahead and figure that out. So basically what I'm going to do here is I want to make a course change when that vessel is about 6 miles away. So I'm going to make this my MX. All right, and I want that vessel to go out about 2 miles. I want a CPA, new relative motion line at 2 miles. So I'm going to go ahead and draw that in there. All right, and you can see that I'm going to take his stern, he's going to take my bow, so he's got to cross my heading flash. So what I'm going to do now is there's some, by the way, here is his true course here. All right, let me get that in there. Okay, what I'm going to do is this is the relative motion line for the current situation, but I want the relative motion line to look like this. There's some good data in here still. Okay, that the other vessel's course and speed is going to stay the same. This line is still good. Okay, I could bring this line down here and make a new 6-minute triangle, but why would I want to do that when this line is still good? I'm going to bring this line up to there. So what I'm going to do is I'm going to do what you might refer to as the M and M hop, MX to M hop. All right, I'm just going to hop this line from here to M. All right, and then let me go ahead and do that. All right, so that hops up to there. Okay, and you can see it just hopped over. I didn't draw it there. All right, now the target vessel is still going to continue on this course, which is something a little bit more than 270. His speed is a little bit slower than ours. We can actually figure out exactly what it is if we wanted to. But right now I'm interested in figuring out what course I should steer. So let's go ahead and figure that out. Well, look, this is my course right now. I'm going 0, 0, 0, and I was going at 15 knots. That's 1.5 miles. Well, what I'm going to do is I'm going to change my course, but not my speed. Well, this is a vector. The speed, the length of this is still valid. But the direction, well, I'm going to change the direction. So what I'm going to do is, this is the advantage of bringing this line over this triangle. I already know that in the next 6 minutes, I'm going to go 1.5 miles. So I set this thing for 1.5, but I'm going to change my course, so I'm going to swing this, okay? And this is now going to become what we'll refer to as R prime. This is the course I'm now going to steer in order to avoid a collision with that guy. All right, so I take that, I get that, and I bring that up to, let me just get that line again. All right, and it looks to me like I got to change my course to 030. All right, the problem target is target 1, and the new course that I want to steer would be 030. Okay, the new course to avoid. All right, if I steer 030, when that vessel comes to this 6 miles, then that relative motion line should change from this to this, putting him about CPA about 2 miles. Okay, and that'd be great. Okay, what if though? Let's say if you looked on the chart, you couldn't alter course to starboard because there was some obstruction there, a rock or something like that. So instead of altering course, we decided we wanted to slow down. Well, what that means is that we're going to maintain the same course, but we're going to decrease our speed. Well, look, the relative motion line is still, we're going to make our change at MX, and the CPA is still 2. This relative motion line is still valid. And guess what? E to M, they're not going to change. So I'm going to make a new triangle now with these two. And now I have to put my leg in there. Well, I'm not changing course, which means the direction of this line is still valid. What I am going to do is slow down. So this is going to become my new triangle. Okay? And this is what we'll refer to R prime prime. And the distance of that is what is proportional to my speed. And it looks to me like that is about 0.7 nautical miles in 6 minutes, which if I multiply by 10, if I reduce my speed from 15 knots to 7 knots, that should allow that vessel to pass 2 miles ahead of me. Okay? Now at this point, or over here, the new speed to avoid. So basically, what we're going to do is, this was our original relative motion line, and we're going to follow that until we get to MX. So what I want to do is I want to find out what time that's going to happen at. Okay, so this was 6 minutes. All right, and that's 12, and that is 6, 12, 18. It looks to me like MX is going to happen at 12 and 2. Looks to me like MX is going to happen at about minute 14. Okay, all right, now. So it's going to take me about, from the original start, it would take about 14 minutes to get to the MX. But now, if I'm going to change my course, this is going to be my new relative motion line. So I'm going to grab this distance, and now I'm going to walk. So where's my CPA? My CPA is actually about right here, okay? So what I'm going to do now is, so that was 14 minutes to there, and I have a new distance of my relative motion, a new speed of relative motion. So I'm going to take that R prime M. I'm going to go from MX, and I'm going to count 6, 12, 18. Looks to me like that's smack dab in the middle. That's going to be another 15 minutes. So 14 minutes and 15 minutes, well, that's going to be 29 minutes. So from the original R, that new time of CPA would be about 29 minutes. Well, what if I, instead of changing course, I slowed down? Okay. Well, MX is still going to be 14 minutes, but now my new speed is going to be R prime prime to M, okay? So I used RM to get to here, which was 14, but now my relative motion is really slowing down. So now this is going to be an additional 6, 12, 18, 24. Looks to me like an additional 25. So 14 and 25, that's 39. Okay, so the new time of CPA for the new speed of advance would be about 39 minutes. Okay, and that's how you can figure that out. I would want to go ahead and take a look at my other targets, okay, and make sure that they're still following their other relative motion lines. I would have executed this course change and then seen what that would have done for everybody, okay? But now that that part is done, I want to take a look at some of these special cases. All right, I'm going to take a look at some of these special cases. So E to R, it says it right down here. Own ship is E to R. Other ship is E to M. So let's take a look at this. E to R, I'm going to go ahead and draw. This might help you visualize if you can't really see this, but E to R, I'm just going to draw a line over here. That is our vector. Okay, we went from E to R. Now what I'm going to do on this side is I'm going to draw a vector that's E to M. Well, in fact, it didn't move. We went like this in 6 minutes, and they didn't move relative to us. E to M is them. There's no motion. That's telling me that that target 1 is dead in the water. Okay? Now this is some kind of crossing situation. Let's look at target 3. I'm going to do that again on this side. E to R, that's our. Over here, I'm going to go E to M. Well, wait a minute. I was going in that direction. They're going in the same direction. I went that distance. They went the same distance. Oh, you know what? This is same course and same speed. So target 3, this is crossing. Target 3 is what we would say is same course and speed. Same course and speed. Let's look at this guy. Okay, so what's E to R? E to R is our. So there's E to R. What's E to M? E to M is them. Wait a minute. What's going on here? Look, we're going the same course. Okay, we're going north. They're going north. But they seem to be going north faster, and they're behind us. Oh, if we're going the same course, they're behind us, but they're going faster, they're going to be overtaking us. Okay? Let's try that up here. E to R is our, and E to M is them. Oh, wait a minute. We're going north, they're going south. Hey, that's reciprocal. Okay, they're on a reciprocal course. Look at the length of those. You know what? Looks to me like we're going north around 15. Looks to me like they're going south around 15. Maybe a little bit less, maybe 12. You know what? I could measure it exactly. All right. There's that. Oh, no, looks to me like they're going south at 15. So we're going north at 15, they're going south at 15. We're on reciprocal courses at the same speed. And although they're going to be a few miles away, we would refer to this as meeting. Okay, you can refer to this as meeting or reciprocal. Okay, and that's how you can use this sort of little vector thing to analyze a special case and determine what the situation is.